Okay, welcome to part one of our videos on radicals. So, first of all, a radical is a name for a symbol that looks like this. And the most common form of this would be a square root. So if you look at it like this, this could be a square root. Like if you had the square root of a squared would be equal to a. A times a gives us a squared. However, a radical can also be a square root is really like that. Technically, you can do a cube root of a cubed, and in a case like this, the cube root of a cubed would be a. So that says that a times a times a would give us a cubed. And in this case, a times a gives us a squared. So if we had the fourth root of a to the fourth, for instance, it would equal a, because a times a times a times a, if you multiply something 4 times, it equals this. So these are all radicals, but it's just the square root is the most commonly used. So we're going to start with the square root for the most part. Alright, so let's start with the product property for radicals. That could be like if we had the square root of a times b. That's the same thing as square root of a times square root of b. Or we could reverse that. We could say the square root of a times the square root of b is the same as the square root of ab. This is going to help us when we're number crunching in examples. So that's the product property. Now let's talk about the quotient property. Quotient property would be something like the square root of a over b is the same thing as the square root of a over the square root of b. We can take and reverse that. So we could say the square root of a over the square root of b is equal to the square root of a over b. That's the quotient property. Another thing we can look at is estimating square roots. So for something like that, when we know the perfect squares, when we know for each number, like 1, the square is 1, we made a column, the number and its square. So we could have 1, 1, 2, square of 2 is 4, 3 it's 9, 4 it's 16, 5 it's 25, 6 is 36, 7 is 49, So it helps if we know those. So then if we try to figure out the square root of 5, we want to estimate it. Well, we know that it's going to be somewhere between the square root of 4 and the square root of 6. Well, let's not take 6. Let's take a perfect square. So we have 4 we know is 2. And let's see, something larger than 5 that's a perfect square would be 9. So the square root of 9 is 3. So we know that the square root of 5 is going to fall between these two numbers. And they're perfect squares. So this square root is 2 and this square root is 3. So square root of 5 is somewhere between 2 and 3. So, and I can't tell from this exactly what it is, but we can give it something like a 2.3, somewhere in there. Of course, it's a lot better just to use your calculator. But if you have to estimate it, this is a method that you can use. Let's take another example. Take square root of 12. So if we look at square root of 12, we look at something that's smaller than that, that's a perfect square. So we can, it's between square root of 9 and something larger than that, square root of 16. Square root of 9 is 3, square root of 16 is 4. So we know the square root of 12 is going to fall somewhere between these two numbers. So we don't know exactly what it will become, but so we'll just say it's like 3.4, somewhere in there. So that's how we can estimate a square root.